What if you could travel through time? Sounds like a sci-fi dream, right? But recent research says it might be more real than you think. Physicist Lorenzo Gavassino has just published a groundbreaking study in classical and quantum gravity, exploring the real-world possibilities of time travel. At the core of his research are closed timelike curves, or CTCs. Imagine a loop in spacetime where you could travel and return to your starting point in time. According to Einstein's theory of general relativity, these loops could exist in certain universe models. Gavassino dives into how spacecraft might behave within these loops. And guess what? He found that time could actually reverse its usual flow. This even prevents those classic time travel paradoxes we see in movies. One key principle in his work is self-consistency. It ensures all events in a time loop align logically, avoiding contradictions like the famous grandfather paradox. Quantum mechanics naturally enforce this, keeping everything in order. The study also highlights the role of entropy, a measure of disorder that usually increases over time. In a time loop, entropy resets to its original state by the end of the loop. This means time would effectively reverse itself within the CTC. Imagine an unstable particle breaking into smaller particles. Normally this process is permanent. But in a time loop, quantum laws require these particles to recombine into the original particle, reversing the process. Gavassino even explores how time loops affect memory and identity. Any memory or record created during the journey must disappear before the loop completes. This raises profound questions about who we are and how we perceive time. So, next time you think about time travel, remember, science might just be catching up with fiction.